So we'll continue which are multi-threading itself now. And till now what we have covered? What is a thread? Okay, thread means what? It's a separate path of execution in the program. So if you are in your program, when you are writing applications, if you want to create separate path of executions, in Java what you do, you'll start creating threads. So creating a thread in Java is very simple. You just have to write the logic in run method and just call the start method. Automatically it start executing. So all that is fine. But right now, to understand how the thread completes execution, you have to understand the life cycle. So that is what we are mainly focusing. So we have come into a stage where now we are discussing about life cycle now. Life cycle of a thread. So this is very, very crucial because next whatever subject we are going to learn, whatever examples we are going to learn will be completely based on this life cycle itself. Means if you understand this life cycle properly, then you can understand all the other. This is the concept now. Okay, this is the concept. So if you understand this concept, you can understand the next following examples. So let me just revise it for you. So when you say thread T is equal to new thread, when you create a thread object, the thread object moves into which state? New state. When you call the start method, then only it will come into runnable state. So a thread in new state is not alive. A thread in runnable state is alive. Okay, so when you call start, from new state it will move to runnable state. So the scheduler will always be keeping a watch onto the runnable state itself. It will be always watching this. Understood? So it will decide which thread to pick now. Okay, and it can decide. And this we can't predict now. Which thread it will pick for execution we can't predict because a lot of factors are depending. Okay, so it will be depending on OS and all that. So there are a lot of factors depending, we can't predict now because in one operating system, one way the algorithm is written and the JVM thread scheduler will be using that particular scheduling algorithm and finally it will pick one thread. So once the thread is picked, now that thread will move into runnable state, running state. So when the thread is moving from runnable to running, first time the run method will be invoked. So when you had created the thread object, when you said start now, the thread has moved into what? Runnable state. It has moved. Apart from moving into runnable state, one separate stack has been created. One separate stack will be created. And in that stack, run method will be at the bottom. Run method will be at the bottom. Okay. So when the thread starts moving from runnable to running, that run method will be invoked. So this run method will be invoked implicitly by the JVM. Implicitly it will be invoked. We can't call it. Okay. So when it moves into the running state, now sometimes from the running state, let's say one by one now. Okay, the thread is executing. Simply it will give up. Automatically, implicitly it will give up and go back to what? Runnable state sometimes. Okay, so why does that happen? Because in some operating systems they will be using what? Time slicing. Due to that they will be giving what? Chances to all the threads for execution. So from running state it might go back to runnable state implicitly. Now explicitly also if you want to send, you can use what? Yield method. Understood? So this is one way how the thread moves from running state to runnable state. Understood? So next, from the running state, see now the thread can move into what? Next state, that is sleeping. So we are discussing more on what? Sleeping state now. So how does the thread go into sleeping state? When you call the sleep method. So now and for the sleep you will give some argument. So based on that argument, means the number of milliseconds, the thread will be kept in the sleeping state. Once the sleeping time is over, then the thread will come back to runnable state. It is eligible for running. The thread in sleeping state is eligible for running, but provided it comes to what? Running state, runnable state. From runnable it will move to running state. Similarly, next, sometimes if you call sleep, it is going to sleeping state, and from running state it will move to what? Sometimes if you call wait, it will move to waiting state. So from waiting state again, if you call notify, only one thread will come back to what? Runnable state. Notify means only one. Which one? And see, now there might be many threads in waiting state. Notify means we'll move only one thread from waiting state to runnable state. Notify means we'll move all the waiting threads to runnable state. And from runnable again the JVM thread scheduler will decide and bring it to running state. So this is how the process will be happening. Now sometimes there are conditions that your thread will be waiting for some resource, or when you call a join method. Okay, when you call join method also what happens? The running thread will get into what? Block state. Okay, and when the resource is available, now it will come back to runnable state. So this is one process. Okay. So now sometimes this will also happen. When the running thread completes execution, it will go to what? Dead state also. Okay. So these are all the different states of a thread. But practically say, from the sun point of view, okay, even though I have written so many states here, from sun point of view, they have classified how many states of thread? Only 5. Which are the 5 states? New state, runnable state, running state, non-runnable state, and dead state. In non-runnable, there are 3 substates. Understood? There are 3 substates. Means it is a part of, sleeping, waiting, and blocked. Sometimes they call it as what? Non-runnable. Why they call it as non-runnable? Because the thread in that state is not eligible for running directly. That's why they call it as non-runnable state. A thread which is there in runnable is eligible for running. And clearly get the point. A thread in runnable, running, and non-runnable, 3 states. Which one? Runnable, running, and non-runnable is alive. A thread in dead and new state is not alive. Are you clear with these basics? Do you have any questions here? And now I am giving you examples for what? Supporting this diagram. So whatever example you see now, again you have to always keep this diagram beside you and then go on observing the output now. Then you will get some idea about what is happening now. Understood? So this is how you have to learn multi-threading. So it is a process. You have to keep the diagram as well as, okay, I'll be showing you all the states today. From running I have shown to sleeping, running I have shown you to blocked, running you have seen to what? Dead. Okay, 3 states you have already seen. From running, simple programs what they are doing. From running they are going to dead state. They are going to, I showed you one program for sleeping, I showed you one program for blocked. Okay, still what I'll do is, I know there are some doubts which are having in the previous programs. Very clearly I know that because that's the first time you have seen multi-threading. That's why I'll revise the same programs for you now. Last time which I executed, okay, the last class I'll revise it for you. Then we'll continue the next class. Understood? No questions with this diagram now? Diagram no questions. So this is the concept now. So how does Java give support to that? With the help of methods, library support. And you can see all the method names mentioned here. Start, run, sleep, wait, join, notify, notify all. So these are all built-in support what you get from the library now, Java library. In other languages, see, you have to learn the concept also. And at the same time, you have to write what? Logic also for all this. But here we don't write logic, we just call a method. So in other languages, it's pretty difficult. Okay, so that's why we say in Java, some of the best features what Java is having, no doubt it's a very user-friendly language, easy language, portable language, all that is fine. Some more extra benefits, what you get if you use Java languages, you got the excellent exception handling mechanism and you got excellent multi-threading mechanism. So due to these reasons, Java is becoming a very popular and powerful language. Where there are a lot of features. Okay, see when Java develop means when a programmer wants to develop something, he needs a good language, and he expects a lot of things from a language. Okay, which for developing an application, because if he has got a powerful language, he can build very powerful applications, robust applications. Okay, so Java goes on to give you all that support, like example, powerful data types, control statements, all that. So many things other languages are giving, but when it comes to these kind of things, advanced things like exception handling, multi-threading and all, okay, the other languages fail away. And apart from that, portability. So these are the more powerful features what Java language is having, built-in it's having. So that's why let's complete multi-threading, then you'll only understand how powerful the language is. Okay, and on top of this powerfulness, what they are giving you? Library they are giving. They are telling don't code, we'll give the library to you. Such an excellent language it is. So always learn language like this. We are having a problem, understood? That problem, how we are getting the solution from this particular language. So developers have various problems, but the problem is you never have a problem. So that is why you don't understand the importance of a programming language. If you have problems, you'll understand the solution now. So do you have a problem? You don't have any problem. So where will you understand the solution? So identify the problems. More problems you identify, more solutions you'll get, and that is when you'll understand the benefit of languages, programming languages. Identify problems. Anyway, see, this is the problem now. What is the problem now you're facing? We want to create multiple executions in a program. Yes or no? So that's why we want multi-threading support. If you develop application, you want what? Multi-threading support. So Java is giving excellent support to that. Understood? So now let's go back to the same program and I show you how you can create multiple threads in Java. The same program we'll revisit. I showed you how to create multiple threads. Which was the program? One, you can create multiple threads by using extends I showed you. Other one I showed you by what? implements also. Preferably we go with implements, but let me cover both the topic for you. So if you want to create multiple threads, what will you do? It's very simple. You'll have many classes. This is by extending thread now. I wrote this code on the last class. Class 1 extends thread. Write a logic. Class 2 extends thread. Write a logic. Forget the constructor. I had explained the constructor concept. All you have to do is what? If you want multiple executions, extend thread, override run. Extend thread, override run. This is one approach. So now how many threads are there? 3 threads. Create object, call start. How many executions have started? 3, no? As simple as this. Which language will give you this benefit? Understanding the problem and the solution, no? So such an excellent language it is. So all you have to do is what? Write the code there. Then you can create objects like this, and then what you'll do? Start calling T1 means, okay, if you want to print the names, that's your wish. This is for printing the name I have done. What is the name of the thread? See, this we are passing the name, okay, to the constructor, and after that we'll call start method. So what will happen now? All the 3 threads get created and 3 separate execution will start. Yes or no? Main is one execution, main thread. Apart from that, how many threads you have created? 3 child threads. So you could have written bigger logics here. I'm not telling no. In A thread you can write some different logic. In B thread you can write some different logic. In C thread you can write some different logic. That's your wish. And you can write 1000 lines of code or whatever it is. Okay. But it is so easy to create a separate path of execution. Are you understanding what is multi-threading now? Are you understanding what is multi-threading? Okay. So this is what is exactly multi-threading. Carefully put, means notice this program now. So and when you run this program, what happens? Begin main, it has created 3 child threads. See the program. Main, concentrate on main now. Only this much you concentrate. It created 3 threads. After creating the 3 threads, you know this constructor now? Last class I explained to you. Understood? So we are giving the thread a name. Understood? So that you check out. So we have created 3 threads. Then what? I'm printing T1, T2, T3. So this is the output of what? Main thread only. The first thread name is what? First thread means one name I have given it as first thread, 2 I have given it as second thread, 3 I have given the name as third thread, and it will print. Then but it was still in which state now? Yes, now you have to refer to the diagram. You have created 3 threads. Okay, so now all the 3 threads are in which state? New state. Main is in which state? Running state. Understood now? So this is, you have to immediately notice now. As soon as you see the programs, you should start understanding now. So main is there. Yes. So what did the main do? It called T1 dot start. Then it called. Okay, it goes on execution. T1 dot start. Okay. So see, the main is executing now. So as soon as T1 dot start calls, what happens? T1 dot start calls, what happens? One separate stack is, it is not created. One new object has been created. Still a new object has been created. T2 dot start, new object has been created. T3 dot start, new object has been created. So all the 3 threads are in which state now? Which state? Refer to diagram. So after calling start, now 1 second, I'm confused. See, first time when you say see, when we created the 3 threads, all the 3 threads were in new state. Which state? This state, new state. All the 3 threads are in new state. When you call start, now they move into runnable state. It's becoming clear now. Very simple it is. So as soon as you call start, yes, I have called start now. So what happens? A new call stack gets created and the thread moves to runnable state also. 2 things will happen. So see the run method now. One run is here. So in the main thread always looks for what? Main method with string args. User thread, for user thread, JM looks for what? Run method. Understood? So this is one user thread. Now next you are saying again what? Again what you are telling? Again you are telling T2 dot start. So what happens? That will execute and move away. Then you will say T2 dot start. What happens? One more stack. It will go to runnable state. Now again you are saying T3 dot start. Again what happens? So these are the 3 threads which have been created now. User thread 1, user thread 2 and user thread 3. And all the 3 states are in which state right now? Runnable state. And main is in which state? Running state. Currently this is the condition, and it goes on to print also. Okay, so finally what happens? End main. See this, begin main didn't, okay, see here in this condition what has happened, it created, and immediately after printing SOP T1, T2, T3 and saying start, what did it do? The thread voluntarily automatically it gave up the running state and went into what? Runnable state. And now from the runnable state, which thread has moved? First thread. And now from the first thread completes execution, it will go into what? Dead state. So see, why you are seeing this output, you are understanding now? So the main thread executed this much, then it went back to runnable. So now in the runnable, how many are there now? 4. 3 child, 1 main. Totally 4 threads are there. So out of the 4 threads, scheduler decided to pick 1 thread. Now from one runnable it came to what? First thread. So from runnable it came to running, and it is going to dead state. So then next one, inside 2. So again 1 has completed execution. Again how many threads are there in the runnable state? 3. 3 are there. Which one was picked? Second one. So that will also come to running. It will go to dead state. That is gone. 1 is gone, 2 is gone. Then next, end main. Which one among the, now how many threads are there in the runnable? 2. Which are there? Main and third thread. Among the 2, main was picked. It comes to running state, completes, execution goes to dead state. Next, third one will be picked, completes execution. Only one is there. It will pick that, executes and gives you the output. But this output is always not predictable. Okay, so in what order you will get the output, you can't predict here. Okay, because in one time you will get the output in one way, because lot of factors are there. So in threads, what is not guaranteed is the order of execution, which is first, which is second, which is third. That is not guaranteed. And also which starts first doesn't mean that that will only start executing first. Even you say T1 dot start, sometimes what happens? Second thread might be executing, third thread might be executing. So the order is not guaranteed. You might start it in any order, it might execute in any order, it might complete in its own order. Okay, you will start it in some order. Okay, it will execute in its own order, and it will complete in its own order. Okay, so this is how it will go on happening. So see the second output. I think I should have copied and pasted it. Anyway, you can see notice the difference now. First time it was a different output. Second time it's a different output. If you want to observe, copy paste into notepad like what I showed you. First time, second time, and see what has happened. Begin main. End only completed all the executions. Means end. Main method. What did it do? It created 3 threads. Run. Okay. So then after the 3 threads were created, main completed execution. Then how many threads were there in the runnable state? 3. Main has come from running to dead state. From running it came to dead state and completed execution. Now in the runnable state, again how many states are there? How many threads are there? In the running there are, in the runnable there are 3 threads. Among the 3, which one is picked? Second one. It will come to running, complete execution, dead. Then the first one is picked. Coming to running, completes execution, then goes to dead state. Then this one. Understood? So the scheduler will always be observing which state? Mainly runnable state. Okay, the scheduler will always be observing 2 states. One is runnable as well as running. 2 states it will be observing. As soon as the thread moves out of a running state, it will pick some thread from the runnable and put it into running. So both the states, no doubt it will be observing all the states. I'm not saying no, but primarily it will be giving more preference to running and runnable. Okay, running is free, one thread will be picked from runnable and moved into running. Running is free, again one more from runnable, moved into running. Running is free, runnable, running. Running is free, runnable, running. Like that it will go on playing. From running again we'll see how it will go to some other states. That is different. Okay, so as soon as running is free, now why does the thread leave the running state now? That might be the next question. Yes, the thread might leave the running state because of various conditions. It might go to what? Dead state. It might go to non-runnable state also. Yes, a thread might leave the running state for various reasons. One of the reason would be non-runnable. Or dead state is okay. Non-runnable means again how many are there? sleeping, waiting, block state, it can go like that. So that is what we have to understand. So are you clear with this flow now? Okay. And yeah, this is how you create the multiple threads, and it's a very simple process now. So order is not guaranteed, and don't think that's the problem of Java language. This is the problem of all languages. In any language, when you create multiple threads, it is very difficult to take control of what? The order of execution in any language. Java is not an exception. Understood? Because lot of factors are there. Okay. Even today's processors are there now. They also play a major role. Operating systems play a major role. The hardware environment plays a major role. Other factors are there. Timing factors are there. So many factors are there. That's why the output is unpredictable, and this cannot be controlled. Are you clear? Okay, fine. Any questions in this program now? If you want, you can see one more output. Go on saying, you'll only understand. Now first one, then end main, then third, and then second. The order is not at all guaranteed. All the 4 threads are completing execution, but what is guaranteed? All threads will execute. That one thing is guaranteed. Okay, all the executions will complete for you. Either somehow they will complete it, but the order is not guaranteed. Any questions here? No questions? In this example, any question? Doubts cleared? I'll move to the next one. So I showed you how to create multiple threads with what? The next program. By implementing. Nothing much difference. Same concept. But we did it with what? Implements runnable. Always implementing is better. We discussed. Why? 3-4 reasons I've given you. You can extend other class, tight coupling what? Thread and the logic. Means you can separate, decouple the thread and the logic. So these are the various advantages if you go for what? Implementing runnable. Okay. So same thing, there's no difference. And you can create threads like this. Pass the runnable object. If you want to give a name, call start. That's it. Same process will happen. Understood? No? There's no difference. As soon as you create the objects, what happens? Same way, it will go to new state. As soon as you start calling start method, what happens? It will start moving into runnable state, and at the same time it will start creating the stack also. And now which one will be picked? It will decide. Okay. So the run method can, again see, here we are in run method, we are printing only one single line. This run method can what? Call what? Other methods, create other objects. In fact, the run method also can create another thread also. It can do anything. It has got the ability. It works like a normal these are all stacks now. This is one stack, this is one stack, this is one stack, this is one stack. So every thread has a separate stack now. We call it as call stack. This is how they have done it in Java. Every thread has a separate call stack. Are you clear with this concept now? Shall I proceed ahead now? So we'll discuss about the next program is what? Is alive, sleep and join. See, the only way you can learn multi-threading is effort. That's why I'm repeating, and repetition. Why I'm repeating is, I know last class you would have coded and come. Because you have coded in last class, I know you are having doubts. Because it's a very new concept. That's why I'm repeating this now. So that your doubts will be cleared. Understood? Okay. Now let's see what is alive and what now? Sleep and join. So we discussed just now. All the threads in which state are alive? The threads in which state are alive always? Runnable, running and non-runnable. The thread is alive in these 3 states. Okay. And thread is not alive in new state and dead state. Now that's the same thing we'll see now. So first we'll go with what? Is alive. Concentrate only on is alive method. Understood? So class 1 implements runnable. This is one class what we are having. Do not focus on this for loop and all that. Okay, just see begin main. I'm creating a thread and t1 dot start. Yeah, we'll see this. Yeah, now you guess the output. We are just checking whether the thread is alive or not. Here definitely it will be what? Here it is definitely false now. Why? Because it's in the new state. As soon as you say new thread, here it is in new state and it is alive is false. It's the return type of is alive is boolean. Now I'll call start. What will happen? It comes to runnable, and in runnable if you print is alive, what happens? True. Understood? Now thread, which one? The child thread may be in runnable or it might move to running. We don't know. Depends. If main thread gives up, then it will move to running and it will complete execution. But if main thread doesn't give, then what will happen? Main thread only continues execution. Here also it will print what? True only. Here also it will print true only, because main thread has not given up execution and child thread has still not completed execution. Only if child thread completes execution, this output will become what? False. So there are chances that here you might get, here you will definitely get true. Here definitely will get true. Okay, but here you might get false or true. We can't predict now. Let's see the output. But are you understanding is-alive method now? See here, false, true, because why it's printing true here? Main thread completed. Child thread still, it is now child thread is coming from after main thread completed execution. Now child thread is coming from runnable to running and completing execution. There are only two threads here. Now you can understand. One is main and one is child, and the child thread is looping. That's it. Clear now? Any questions here? You understood is-alive? Okay. Now what I'll do, I don't want the main thread, understand my problem now. I don't want the main thread to complete before what? Child thread. I want main thread to complete after child thread completes execution. Let's see what approach we take now. So what I can do is, I can put the main thread to sleep for what? Some time. I'm giving you some rough time. I don't know like how long the child thread will take now. It might take 1 second to complete, it might take 2 seconds to complete, because it all depends on the logic you have written in what? Child thread. We can't predict how long the child thread will take time for completing execution. We can't predict. Roughly I'm putting some time. What is the time I'm putting? 5000 milliseconds. I'll put now which one? Main thread to sleep. Now even if main thread is executing now, where it will go now? Sleeping state. Now running state is free now. What will happen now? The scheduler, as soon as it sees running state is free, it will send from runnable to running. It can send any thread, but in runnable how many threads are there? Only one. So it will send the same thread. Right now I created only one thread here, no? So if main thread moves out of running, then obviously T1 has to come from runnable to running. It will complete the execution. Okay, means we don't know whether it will complete or not. It is executing. Okay, but as soon as this 5 seconds are over, what will happen? Again it will come back to runnable. By that time child has completed, fine. Again otherwise anything can happen. That's the problem. Okay, let's see this. Anyway, one of the way, yeah, we'll see this output now. See here what has happened. Begin main. Child thread. Now see the last you saw the output. 5 seconds, after 5 seconds it printed. Just see the output again. See, main thread is waiting for child thread to complete execution. Now it will print. Understood? It was waiting. Okay. So see, begin main, fine. False, true. Till here who was executing? Main thread. Suddenly when you put it to sleep, where did it move? Open the document now. Main thread was running. From there it went to what? Sleeping. Who was there in runnable? Child thread. So as soon as this is free, it will come to runnable. Sorry, running. It will complete its. It is doing its execution. It is doing its execution. Till then, what is happening? Main thread is sleeping here. Main thread will complete off its execution, and it does not have any computation here because there is only one thread. So it will complete off the execution, and now after this completes execution, still what? The program is not over because one more thread is in sleeping state. Then it will come to runnable state. From runnable, it will come to running. Then after completing execution, it will go to dead state. Open diagram and learn. Without diagrams, you can't understand here. That's why with so much of effort I give this diagram to you. Clear this? This is one of the best diagram you'll get in what? Multi-threading. If you go anywhere in internet, you'll not find this diagram. This is with experience I have put. It is my own visualization and I have put this diagram now for you. Understood? Means if you understand the subject very well, then you can see all authors are trying to do what? Understand the subject and give some information. Now they can give drawings in their own way. End of the day, their drawing is a message to you. Understood? Same way I am doing. So in internet, if you see some other diagram, don't tell no this is wrong or that is wrong. Don't compare. All authors are trying to do what? Just give their own diagrams. Why I told you that is because in internet you'll find different diagrams. As long as you understand the concept, diagram becomes secondary now. Are you clear with this? Are you comfortable with the program now? This output? Okay. So again, if you want, you can see the output. Always, yeah, this is the output what you can expect here. The same output, because thread is going to sleep for what? 5 seconds. Here it is almost all predictable, because you are putting the main thread to sleep. But now the problem is, when will, okay, now next, not only main, I can even put what? Child thread to sleep. Just learn how to put all threads to sleep now. Again, also put what? Child threads to sleep. This is also one more option. But sleep method will cause what? It's a interrupted exception. It's a checked exception. Whenever you call sleep, what happens? You have tried it in try catch or you have tried throws. Okay. So I'm writing try catch. Now see this. Now main thread also, see how it will go on executing. A very interesting flow now. What's happening? See the output again. You have to understand now what is happening here. From new state, see main thread created what? One child thread. Main thread created one child thread. The child thread went into new state. Child thread is in new state. Main thread is still running. Now when the main thread calls start, child thread comes from new state to runnable state. It will come now. And main thread is still in what? Running. So to summarize, main is in running state. Child thread is in runnable state. This up till here clear now? Main is in running state and child is in runnable state. Now when main goes to sleep, main thread goes to sleep, what happens? Child thread comes for execution. So it is executing. See this run by cluster thread 0, it is executing. When it was executing, what's happening? Child thread is also put to sleep. Yes or no? Child thread is put to sleep for how many seconds? 500 milliseconds. Now child thread also moves to what? From running, both are in which state? Child thread and main thread both are in sleeping state now. But main thread is sleeping for 5000 milliseconds. Child thread is sleeping for 500 milliseconds. Both are sleeping. So no thread is there in what? Running. And scheduler is in runnable. Is there any thread? No. So it can't do anything. Okay. But anyway, there is no thread in runnable also, running also. But immediately what happens? After 500 milliseconds, which thread goes to runnable now? Child thread. Again that thread only will be brought into what? Running state. Again it will execute. It's a loop. 5 times you are looping. So again it will execute for 500 milliseconds. Again what happens? Sleep. Goes. Again comes back. Like this it goes on cycling. Only child thread will be moving from. Understanding the flow now? What now? Runnable, running, sleeping, runnable. Are you getting the flow? Runnable, running, sleeping and runnable again. Okay, means we are seeing now why does the thread move out of running state? When you call, one of the reason why a thread moves out of running state is when you call sleep, or other reason you know already, when the thread is dead. So these are the various reasons why a thread moves out of running state. So I have covered two now. Which one? Sleeping and dead state. Sleeping state and dead state. So these are the two means one of there are many reasons. There are many reasons why a thread moves out of running state to other states. Two reasons which I have covered now is sleeping state and one is sleep method and when the thread goes from running state to sleeping state, and one reason why it goes is to dead state. Why it will go to dead state? When the thread completes execution. Why it goes to sleeping state? When you call the sleep method. Clear this now? You want to see the output again? See, no problem. First see the code here. What is the child thread doing? It will print. And then what it is doing? Going to sleep. So on SOP it will do and goes to sleep now. Are you clear? This all code you know now. I am just calling what? You have started, everything is same. You are just calling what? Sleep there also, here also. Clear? See there, the child thread. It is not executing in one go. But if I remove that sleep, notice the flow. If I remove the sleep in what? Child thread, it will never go to sleeping state only. Directly from running it will go to what? Dead state. Only main is sleeping now. Understanding now the flow? Fine. So I have to take examples like this. So more examples you see, more clearly you'll understand. Single example you can't take and try to understand the whole subject of what? Multi-threading. So all my examples are again concept based. One example for one concept, another example for another concept. Clear this now? Yes. Now the problem here in this program is what? Main has to wait till the child thread completes execution. But how long will child thread take now? That's not guaranteed. So what we can do is, we can use the join method. Now I am coming to which one? Join. Are you clear with is alive? Are you clear with sleep? Shall I go with join now? Join, I'll give you some more examples. You'll start understanding join very clearly now. Understood? Some 2-3 examples I'll give you, I'll start understanding now. So call join now. Finished. What will happen now? When you call join, what happens? The calling thread will join to the end of the joint thread. The calling thread will join to the end of the one thread is joining you now. The calling thread will join to the end of it, bottom of it now. So till that completes, this will not complete the execution. Let it complete whenever you want. Okay, but it will definitely sorry. Like T1 dot join, see this? It is guaranteed that which one? Child thread completes first, and then only whatever you do, you'll see end main here. Whatever you do, because it has joined. Understood? So now see, I'll put the child thread to sleep for how many seconds? I'm not putting the main thread to sleep. I'm putting which one? Child thread to sleep. See the output last, end main. So what happened now? The calling thread, who is the calling thread? Main. Now main will join to the end of the joint thread. Some thread is joining now, it will join to the end of it. So main thread started off. See, main thread started off. Okay. See, till now without join, it was like this. First I show you without join. Well, right, okay. Without join, there are two threads. One is the main thread, the other one is the user thread. Both have their own separate path of execution. Without join. When you say join, who is joining now? The calling thread will join the other thread. So when the calling thread joins the other thread, what happens? See, this is main thread. Who is the calling thread right now? In our program, the calling thread is main thread. So the child thread will join here now. Or the user thread, it will join here. That means it will come in the between, in between it will come. And after the end of it, which will be joined now? So means we say actually the calling thread joins to the end of the joining thread. The calling thread joins to the end of joining thread. The calling thread, when you call join now, the calling thread joins to the end of joining thread. Very simple. So it is joined here. I'll give you some more examples on join. You'll get very clear clarity on that. Understood? So it is joined now. Are you clear with this? So what will happen now? Till child thread completes, main thread will not complete. Are you clear with this concept now? So I'll give you some more examples where your concept of what? Join will become more clearer. First understand this simple example. Understood? First understand this simple example. So see, whatever you do now, it will always execute what? Whatever you do, you put the child thread to sleep for even 1 hour. Main thread is not going to complete now. It is still waiting for the joint thread to complete execution. Now in which state will the calling thread be now? That's the next question now. Child thread is executing, but what about the state of the calling thread? So it will be in blocked state. That is the next one now. See the diagram. It's very clearly mentioned. Join. Where it will go? Block state. It leaves the running state and moves to block state. So till it completes, when resource is available, Instead, till that completes execution, it will never complete the execution. Clear now? Very simple. Okay, this is one example. We'll see more examples on join. This example is clear now? This example is clear? Okay, see, I'll create multiple threads and join all the child threads to what? See, there is one class called as P, there is one class called as Q, there is class called as R, multiple threads. I want all the child threads to complete first and then what? Main thread to complete execution. You know how to create multiple threads now. All I do is what? Go on joining, that's it. The first thread is joined, the second thread is joined, the third thread is joined. They will have their own path of execution. Context switching will be happening between what? Thread 1, thread 2, thread 3. That is secondary. They will have their own path of execution. But till they complete, main thread has sitting to what? Sitting in block state. Understood? Till they complete execution, all the three. Okay, whichever one, now here, whichever one can complete execution first. Or it is not guaranteed. Either T1 can complete, T2 can complete, or T3 can complete. Understood? But all threads will complete execution after, because all the threads are joined to main thread. This is the calling thread now. Who is the calling thread now for all this? Main thread. So all have joined this. So what happens now? Main thread will complete execution last. That's it. So you can see now. See end main. You can see this output. Whatever it is, whatever you do, main will complete last. PQ or order can vary. Either P will execute first or Q will vary execute first. That you know now, flow now? How it will vary? Okay, means all are in runnable state. Anyone can come from runnable to running. P can be picked or Q can be picked or R can be picked. P means P will be picked, comes to running, goes to dead. Then Q and R are there. Where? In runnable. Q and R are there in runnable. Okay, so again Q can be picked, it comes to running, it goes to dead state. R will be picked, comes to running and it goes to dead state. Now after all of them complete execution, till now main thread was sitting in block state. From block state it will move to runnable. Remember, from blocked again it cannot come to running. From blocked it moves always to runnable only. From runnable it will come to running. So this is how it goes on moving. Are you clear with this flow now? So always from non-runnable it has to go to runnable. Means the meaning of that is, from runnable, why it has to go to runnable means it should become eligible for running. Only the threads in runnable are eligible for running. Non-runnable threads are not eligible for running, but they are alive. Non-runnable threads are alive but are not eligible for running. That's the meaning of it. Runnable threads are alive and eligible for running. Not alive, sorry, not eligible, eligible. Both alive only. Both the cases, non-runnable and runnable, alive only. But difference is whether it is eligible for running or not eligible for running. Clear with this? Any questions in this program? I think I don't have to write this. Okay, if you want little, I'll show you. What exactly happens is, see, I'll show you without join first. Again, I'll just comment this now. Which one? Now what happens? Order is not guaranteed because you are not joining. 4 threads are there now. P, Q, R, main thread. Anyone can complete execution. So see the flow. Begin main, end main. Main only completes first. Then after it goes to dead, P will be picked, coming to running, dead. Q will be picked, coming to running, dead. R will be picked, coming to running, dead. Clear na? So this is how it goes on executing. So here what happens, without join, how many threads are there? This is a diagram for that one now. 3 user threads are there. User thread number 1, user thread number 2, user thread number 3. 3 stacks. Okay, this is P thread, this is Q thread, this is R thread. All are user thread 1, user thread 2, user thread 3. Main thread is another thread. Understood? There are 4 threads now totally, and anyone can be picked. Understood? But if you do join, what will happen? Can you guess? P thread also will come here. Understood? All have been joined to what? This will be the diagram now for this one. This is P thread, this is Q thread, and one more R thread. All are joined to main. So when P, Q, R all complete, then only main thread will complete execution. Simple difference. Diagram wise. Are you following now? And here P can complete first, Q can complete first, R can complete first. We don't know. Either P or Q or R. But understand the diagram very clearly. Are you clear this? P has see who is calling now? The main is calling. So all the threads are joining to main now. First P joined, then Q joined, then R joined. It will complete the execution. Are you clear? Okay. Now we'll come to the assignment which I had given to you. If you are comfortable with this, then I'll come to the assignment I had given to you. A, B, demo, all that. I'll come to that. Are you clear with this diagram now? Any questions here? No questions? Yeah, in the last class, what was the assignment I had given to you? I want one child thread to join another child thread. Here all the threads are joining what? Main thread. But that's not my requirement now. I want one child thread to join another child thread. I had given you the code now. Did you try it? Did you get the output? Did you get the output? Yes, no? It's a very simple program. So there what was happening? You are joining one child thread to another child thread. Okay, so it's very simple now. Example. Here I have taken the class name as X, implements, runnable, public void run, you write. Right, you write the logic, just a second. Class Y implements runnable. Here also it is there. My intention is what now? I want, okay, first see this demo also. Yes, my requirement is I want X thread to join what? Main thread. This you know very well. You can say thread T1 is equal to new thread of what? New X, if you want to give name, there it is. Okay, T1 dot start, and then what you will tell? T1 dot join. That's it, over. Now X thread has joined what? Calling thread, and the calling thread is main. Understood? Are you clear with this concept? Fine. Now my requirement is I want to create one more thread, but that should join what? X thread. So now here, see this thread T2 is equal to new thread of new Y. You are creating an object of Y. T2 dot start, T2 dot join. Finished, over. If you want, you can print some statements here. SOP begin X is SOP begin, sorry, end X, all that prints you put, and it throws exception, you know that, join method, put it in try catch. So what is the flow now? See, first main thread, it will create one thread now, main thread, it will create one thread, this is main thread, okay, it will create which thread? X, and X will join to what? Main thread. X will join to main thread. X is joining to main. Now what will X thread do when you execute? It will create one more thread, and Y thread will join what? To X thread. Understood? And after Y completes, X will complete. And after completes, X completes, then main thread will complete. Are you understanding the flow now? Let's see, the joining thread will join to the end of it. When main thread join, now it join to the end of what? X. But when X is joining, that will come in between. Now which one? Y will come to the middle of? Means Y will come after X. Y will come after X, and just you get the flow now. So means main thread will come first. Which one will complete now? Y thread will complete, then X thread will complete, then main thread. This is the order of execution. Okay, so you are seeing many concepts here. One is how one child thread can join another child thread. That is one concept. Yes, no. Other concept is what? This is an interview question for you. Can one child thread create another child thread? Yes, you can create. Now whether you join or not is secondary. Whether you join or not is secondary. But one child thread can create what? Another child thread. How will you create it? In the run method, thread T1 is equal to new thread, if you say, automatically another child thread gets created for this one. Are you clear? So plenty of concepts are there. So again, more questions will come in interview. What all can the run method do? Anything it can do. It's like which one now? You can even create objects there. You can call methods. Okay, you can start another thread. Anything you want, you can do it in run method. It's a separate stack now, and all the things will go on executing in that stack. And context switching will be always happening between what? These stacks. I was talking about context switching now. Context switching is happening between stacks now. This stack, this stack, this stack, context. I'll show you next example. Very clearly I'll show you context switching. Understood? Context switching will be happening between all the stacks. Now that itself, context switching will be happening between the different stacks, and we say stack is nothing but what? A separate path of execution. So between different execution, the context switching will be happening. So shall I show you the output for this? This is code. Only I have to write try catch, that's it. Otherwise everything is fine here. If you want, you'll write what? SOP begin Y, SOP end Y. So actually you predict the output now. SOP begin main. So now in multi-threading you have started predicting output. That is really great. It's very tough subject. Understood? Now what happens? Begin main. Then what will happen? Begin X. Then what? Begin Y. End Y. Comes back. End X. End main. Great. If you're getting this much control in multi-threading, more than sufficient. Understood now? Clear this? Any questions? But previous program, how was the join happening? There were 3 threads. All the 3 threads were joining what? Main. So understand the concept of join. First join was this. What was the first join I did? I removed it anyway. Only one thread was joining the main thread. In the second example, what did I do? All the 3 threads I see in the first. This is second example. This is the third example. In the first join, I showed you something. Now what was happening? The child thread was joining main thread. Very simple it was. This is the first one. I showed you join. Is alive, sleep, join. This is the diagram for that. Okay. Then I showed you 3 threads joining main thread. This is the diagram for that. Then I showed you what? Child thread joining other child thread. This is the diagram for that. Yeah? I show you the output now. Shall I clear what I have written? Any questions? And the join is a very important interview question for you. See this, the heading is what? The 9th example. Join thread to child thread, join child thread to child thread. 9th example, you can go through that. Same thing, X, Y is there. What? Main. Main is joining which one? X. And X goes on to join what? Y. X goes on to join Y. That's it. And Y nothing is there. Begin Y, inside Y, end Y. So that's the output you'll be seeing first. Means first it will start with begin main, begin X, begin Y, inside Y, end Y, end X, end main. Guaranteed output. Because you are joining now. Begin main, begin X, inside X, begin Y, inside Y, end X, end main. So now see the flow. Begin main. The main begins execution. T dot start and T dot join, you are done. So it will go to X. In X, these 2 statements are printed. Yes or no? Begin X and what? Inside X. Now begin Y means it will shift to what now? It goes on executing. It comes to this line. Okay, and it will join the Y thread. Begin Y now. inside y, begin y, inside y, end y. Then it will come back to x, the pending statement. In x, then end me. Clear? Any questions? Any questions? No questions? Done? Document. We had discussed about what? Sleep and join. Any questions in this? The join method joins the current thread or calling thread to the end of joint thread. I had also given you one point now what I gave. Calling thread joins to the end of joint thread. Simple, that's it. And all this I had explained to you last class. Join method, why to use it. You can write it down if you want to. When to use join, if there are two threads, you can do all that. Clear? No questions on that now? Yeah, so we'll see some more examples on multi-threading. Yeah, so till now you saw from what state? We'll go back to the diagram. Keep diagram and learn, see all the programs, then you'll understand. So it is with this visualization I have prepared the examples also and document also. Only you can understand the document and the examples. Others can't understand this document also, example also. You give it to your friends, they will not understand. Parallelly I am moving. Document with what? Example. So here only you clear all your doubts. Understood if you have. Yeah. So I went on to show you what? New to runnable, runnable to running, running to dead. Yes? I showed you in dead now? We are covering all the states one by one. New to runnable, runnable to running, running to dead. From running we saw sleeping, from running we saw blocked. Okay. Now what I will be showing is, from running I will be showing you runnable. Understood? From running it will go back to what? Runnable state. It will go automatically, it will go. I will not do anything. Understood? So if you have if you have very lengthy code in run method, that's all. You have to means you write many lines of coding where in run method. It will be executing. Suddenly what will happen? The run method. It will give up and go to runnable. Another thread will come from runnable to running. That's it. Nothing more here. Very simple concept. Understood? So for the demo, instead of writing very lengthy code, what I have done? Very cleverly we do what? Looping. 50 lines I am looping. That's it. So this goes on to loop for some 50 lines. Which one? A thread. See, I am creating multiple threads. I am creating multiple threads. A thread, B thread, C thread. I am creating now. You create it either by extending or implementing, secondary. But I have created 3 threads now. In all the threads what I am doing? Same logic. Just I am looping. Okay. So I am just looping now. See here. Till now here what we are writing in the run method? Only inside A thread. Extra what I have written is loop. And in A thread I am using a variable called as I. Notice that. And I am printing what? From A thread I is equal to I'll print. In B thread what I am doing? I have used a variable called as J. So I belongs to A, J belongs to B, and K belongs to C. That's it. Same process. I'll call what? A is equal to new A, B is equal to new B, C is equal to new C. More than that nothing I am doing. Just I have added on loop. Now 3 threads will start off. Means all the 3 threads will come into what? Runnable state. From runnable, 1 thread will be picked. Which one we don't know. It will come to running. When it is executing now, it will only go back to what? Runnable state. So this is one more condition why a thread goes from running state to some other state. That is runnable. So this time it is not going to non-runnable. It is not going to dead. From running it is going to what? Runnable. Till now we are seeing from running to dead. From running to non-runnable. Now we are seeing running to runnable state. Very simple program. Very simple program. There is nothing here. So just see the output and you have to run it 3-4 times. One time you will see one output, then you will get the idea about this. See J, okay, here continuously B is getting executed. It has not given up, continues. Okay, see here. A is executing, it goes on to execute till 8. After the 8th iteration, what's happening? C has started off, and C goes on to complete the execution, and then A is picked again. I didn't do anything for what? Did I do anything for A thread? Why did it leave when it was executing the 9th iteration? No reason. And if you want to see the code here, in A, no, what is the code I have written? Have I written any code to go back to runnable state? Nothing. I didn't say sleep, I didn't say anything, I didn't say. But automatically it is only going back to what? Runnable state. One more execution you see. I'm on the top. Okay, see here A goes on executing. Yeah, sometimes you'll see full control. Sometimes when thread is chosen, no. Till it completes, scheduler will not leave. We can't predict. Sometimes it will give up, sometimes it will not give up. So B goes on. Yeah, fully. C, fully. Okay, fine. Let's see one more time. Still here also the same thing. What you do, you just increase the iteration levels and get the clear picture now. 500 I'll do now. Understood? 500 means assume that there are 500 lines of code now. In A class there are 500 lines of code. In B runnable there are 500 lines of code. In C there is 500 lines of code. Instead of writing 500 times, I am using a shortcut now. That's it. So means there is some lengthy code now. It can be calling other methods, something like that. So now see. It will finish. Execution will happen faster. Don't worry. Okay. But the output you have to understand. Go on to the top. Start understanding now. B has started. Oh, still continuing. Fully it is continuing. Okay, see here it gave up. At 487 it gave up. And which one was picked? A. Begin A. But again what happened? A also is given up immediately. A also is immediately given up. It didn't even execute one also. Again which one was picked? B. After B, two things got executed. Then what happened? A is getting executed again. To what? 0. Means till here B was in running state. Now it moved back to what? Runnable, and A came from runnable to running. Again A gives back and goes to what? From running to runnable. Hardly it printed begin. It didn't even do one iteration. Goes back from running to A is going back from running to runnable. Which one was picked? B. It continues from where it left off. Wherever it was left off now it will continue. So it will print only 2 now. See there? Now again B goes back to what? From running it is going back to runnable. B. It is printing only twice. 488, 489. From there again it goes back to what? Runnable. Again which one is picked? A. Again A goes back. Which one is picked? B. Now see. This one, that one, this one, that one. Unpredictable. Means what you have to understand is there are 3 threads. One thread is coming from running to see there are 3 threads. There are around 500 lines of execution now. Okay, all the 3 threads have 500 lines of execution. So from runnable one is continuously executing. Suddenly it will give back and go back to what? Runnable. And any thread can come now. And by the time it is even executing one line, again it will go now. Again any thread can come. Again any thread can come to running. Like this it will go on happening now. So it is unpredictable. So what is the subject about now? Moving from runnable to running to runnable to back to running now. So like this it goes on now. Understood? So if you have written some too many threads, and definitely in your in run method you will not write SOP. You will be definitely writing what? Many lines of coding. If you are not writing in run, you will be writing in other methods. You will be calling that method, like that it will be happening now. So like this all threads will be executing. Are you clear this now? This happens in Windows OS now. That's one more thing. Okay. And in Linux how it will work? Can't predict. So here that they are giving what? Some time slicing they are doing. Understood? So trying to give some chance to all threads. Trying to get the end of, why are they trying to give time slice? They don't want only one thread to dominate. They don't want only one execution to dominate fully. So that's the reason what they'll do. They'll try to give chances to all threads like this. That is their intention. Understood? So you see from their point of view. Don't see it as confusion. Because if only one thread goes on to complete execution, what will happen? All other, then there's no point of writing what? A multi-threaded program only. So that's why they try to give chances for all the threads. Okay, on what grounds they write logic, it's up to them. So all operating systems, they have their own idea for increasing what? Having their applications now to perform in a better way, they will write the logic in their own way. Which one? Windows will write in their own way, Unix will write in their own way. All the applications will run on operating system only. So they'll be using a lot of brains and writing it. Our scheduler will be using that scheduler now. And that is the reason why this happens now. I'm telling you the reason why the chance is given for other threads. So it is not confusing, it is good only, because in applications this is needed. Are you clear? Otherwise simply Windows will not write such kind of code. Yeah? So again, if you want, you can run once more, see what happens, and you don't expect the same output what I am showing you here. See J. We don't know what will happen, when it will happen. Continues fully. Yeah, it has dominated fully this time here. It has dominated. The thread has been dominated. B thread went on to dominate fully. Now A thread starts off. It is also dominating fully and not giving a chance to what? C thread till last it is not giving. It's not giving. And then C will start. Sometimes you'll see another output. So can't predict. Sometimes they dominate, sometimes they don't dominate. Start from the beginning actually. No, especially I think in laptop there will be lot of variation more than CPUs, because in my laptop I was seeing too much of variation when I was coding this. No? In my laptop I saw like even for 2020 iterations also it was moving. Okay, try it in your laptop, might be it will happen. Okay, so I told you a lot of factors, hardware factors, operating system factors, lot of factors, processor factors. Anyway, you got the idea of what is running to runnable now? Okay, and this point has been documented. Where it has been documented? See, don't worry about the yield method now, we'll come back to that. I'll talk about this point now. Which point? In some JVM, look at this point, the sixth point. JVM which use round robin scheduling algorithm, the thread implicitly or voluntarily gives up control and moves from running state to runnable state to give a chance to other threads for execution. It has been documented. And to make you understand that point, this is the example. Understand now? If you are doubt, then refer to this. Runnable, running to runnable. Yeah? Fine. That's it. So here you can increase. I've kept first you start with 50, then if it is not visible, then you make it to 500. If it is not visible, max you make it to 1000. Otherwise you'll have to keep on scrolling. That is more than sufficient. Fine. Now we'll come to something called as priority based scheduling algorithm. Priority, thread priority is the, okay, sorry. I'll first complete off yield method. See, these are the methods which we discussed, which affect what? The life cycle of a thread or the different states of a thread. If you call any particular method, it will be affecting now. Two we discussed, sleep and join. Okay, so we are completing the methods of which one? Class thread today. Run, start over, sleep over, join over, yield over. Yield I'm going to tell you. Do not bother too much about yield, just understand theoretically, don't want any example. Okay, just understand this. So when you call yield method on the running thread, then it will be moved back to what? Runnable state to allow all other threads of the equal priority to get their turn. Means it will give chance to equal priority thread. Yield method will give chance to equal priority thread. That one point you understand, that's more than sufficient. Understood now? Fine. So that's about yield. So we have completed all the methods of what? Class thread, interface runnable also over. We have to complete these methods, sorry, which we'll be doing very shortly. Means next we'll be doing that. Are you clear this? Fine. So next we'll move to thread. The next heading, thread priorities. Understood? Thread priorities. So what is thread priority? Priority, see, go through this document, very simple I put. Okay, priority is a number which is given to what? A thread. This, after this document I'll give the example for you and you'll understand it. This number is ranging from what? 1 to 10. 1 is the minimum priority, 10 is the maximum priority. And in class thread there are 3 constants defined related to this priority. Understood? There are 3 constants. So again I am introducing what? Members of what? Class thread. You can, if you open the document, if you open which one? The document. Very clearly you can see. Yeah, max priority, min priority, norm priority, and static int. They are static. So always static final variables will be declared as what? Caps. 2 or more words, underscore. Remember the syntax. The maximum priority the thread can have. The minimum priority the thread can have. More information you can see. Okay, it's the maximum priority. Constant field values. You click there. What it is? Okay, fine. Leave it. Okay, means it will go more deeper. Fine. What I means the again what you have to understand is the value of min priority is 1. The value of norm priority is 5. Actually, if you print no SOP thread dot norm priority, you know what is the value it will print? 5 it will print. Print it and save because it's a static final variable. Okay, and you cannot modify it also. Just print SOP thread dot max priority. I'll print and show if you want. It will print 1. Norm priority will print 5. Min priority will print 1. That's the value, which means that is the value stored in these variables. Fine, now see this. In thread class, there are 2 methods related to priority. Which are there? Get priority, set priority. These are the 2 methods which are present in what? Class thread. So totally how many members are there related to priority? 3 variables, 2 methods. Understood? This is very important from my interview point of view. Okay. 3 variables, 2 methods. And now get priority is what? Is for getting the priority. If you print SOP T1 also, it will print everything. Thread name, priority and group. Sometimes I don't want all the information. Just I want the priority. What do you do? T1 dot get priority you call. Return type is what? Int. You can find out the priority of a thread. Understood? So that is what is get priority. So get priority will print you what? The get priority of the thread. Set priority will do what? Sets the priority. You already done it. I'll show you some more examples. You'll understand it clearly now. Fine. See, when there is no priority set for a thread, then what happens? That is very important. It will set a default priority. But what is that default priority? Very tricky interview question. Definite interview question. Okay. So it sets the default priority of the thread that creates it. Some thread will be creating another thread now. Main thread will create child thread will create another child thread. So which thread is creating it now? That priority will be provided. Means, see, for example, if A thread with a priority 7 creates another child thread B, then the newly created child thread B also will have same priority of 7. Till now main thread was creating child threads. So that is why we are getting the priority as 5. Understood? But if some other thread with a higher priority thread, which priority creates another thread, default it will create that. If you want, retain it, else change it. After creating the thread, what you can do? T1 dot set priority. From that priority, it will change it to some other. I'll show an example, you'll understand. Clear? Fine. Now, see, thread priority concepts will be useful when your operating system is supporting preemptive or priority based scheduling algorithm. Otherwise, no use. If your operating system should support this, then only if it's good you use all this, which one? Priority and all that. If it is not supporting, only if you write code also, what is the use now? Understood? So before you write priority based logics and all, first understand whether your operating system is supporting it and then write logics. Fine. And Windows supports priority based. Windows operating system supports what? Priority based scheduling algorithm. So in the case of priority based scheduling algorithm, the thread with the highest priority will get the CPU time first. The thread with the highest priority. What is the meaning of that? Very clearly we'll see now. The meaning of that is, say, if a thread enters the runnable state, one thread will enter now. Into which state? Runnable state. And it has a higher priority than what? All other threads which are present in runnable state. So it is having higher priority than all the threads in runnable state. A new thread has entered into runnable. It is having higher priority than all the threads present in runnable state. Apart from that, it is having higher priority than the running thread. So it is having totally, if you see overall, it will take the consideration of what? Running thread and runnable thread. Running thread priority also JVM will see. A thread scheduler. Running thread priority also it will see. Runnable thread priority also it will see. If the runnable thread is having which one? High priority, immediately the running thread will be moved into runnable, and the thread in the higher runnable state with highest priority will be brought into running state. Very simple. I'll give an example, you'll understand. But understand the concept first. If you understand concept, then you'll understand example. So here, for example, thread A, B are in which state? Runnable state. A and B both are in runnable state. Another thread C is in which state? Running state. So two threads A, B are in runnable, C thread is in running. Priority of A, B is what? 4 and 5. Priority of C is what? 6. Priority of A and B is 4 and 5. Priority of C is 6. A and B are in runnable, C is in running. Now we will enter, D thread will enter. With what priority of 9? Where it will enter? Runnable. First it will enter runnable. As soon as it's enter runnable, what will happen? Now the scheduler will move the lower, see here, thread A, B, A and B are in runnable state with priority 4 and 5. Another thread C is in running state with priority 6. At the same time, another thread D with priority 9 has entered into runnable. Okay, so now the scheduler will move the lower priority thread to C to runnable. It will move the lower priority C thread to runnable state and gives the chance for what? D, because it is having the highest priority. It will move C out of running state to runnable and give the preference to D. In case of non-priority based scheduling algorithm, there is no use of this value. There is no use of this value. Now what values are allowed for the priority of a thread? You might have a question. Values are from 1 to 10. This is your interview question now. These are interview questions. What is the default priority of the thread? I just now I told you. The default priority of the new thread depends on the priority of the thread which is creating it. For example, if A thread with the priority 7 creates another child thread, B, then the newly created child thread will also have the same priority of 7. Understood? Then next, what will happen when you give a value greater than 10 or less, out of that range, greater than 10 or outside 1 and 10? If you give, what happens? You will get an exception called as illegal argument exception. This is one of the important integration. It will compile because see, set priority is asking for an int value. You have to give an int value, it will compile. But during runtime, problems will happen. Are you following now? So I have to give an example for this. Let's see an example. See, there is one P thread, it's also looping 5 times. And there is one Q thread, it's also looping 5 times. There are 2 threads. And I'll create it. You know how to create now? P T1, Q T2. And I'll set the priority. See, like this. In fact, when you set the priority now, you can write like code like this also. Directly you can say what? 10. Valid. Highly valid. But we generally provide it like this. Why means, as soon as anybody sees now, 10, it is not that much informative. But if I say max means okay, this is having max priority. Because see, even though we know 10 is having the highest priority, we need more clarity in coding. So that's how you use this. 10 if I give also it will work. Thread.max priority if I give also same output. But preference is always given like this. Okay, see now first we'll see the output. So there are 2 threads I have created, and now for the first thread I am giving what? minimum priority, and for the second thread I'm giving what? Max priority. Means P is minimum, Q is maximum. And I start both the threads. Many number of times, not always, I'm telling you, many number of times you'll be seeing what? Q given the preference first. Many number of times. Understood? And see here, it is a very small program, so you can't fully predict it. In bigger programs, very clearly you understand this concept. Yeah? Okay. Many times you'll be noticing Q will be given the preference. Even though I start at T1 first, Q will be getting the maximum preference. Many times, but sometimes you'll see P also. Don't get doubt. See now P. It picked, but before it was pulled back to running, program only completed execution. It was only 5 iterations, no? So before it moved back in from runnable to running, it completed the execution. Okay. So you just better understand what? Theoretically priority, more than that you don't bother about this. I'll give you an example, but just bother more theoretically about this. Fine. Now some more things here. Always when you set the priority, now see, we generally say like this. Thread, if I want to give 8, no? See, if I want to give 10, what will I do? You can say 10. Same output, there is no difference. But if anybody sees the code, will they get clarity on that? 10, 1, it looks very odd. So that's why what we do, we actually try to use what? Thread dot max priority, like this we do. Understood? Sometimes you want to give 8. Now what will you do? 1, 5, 10 is easy. I can tell what? Mean priority is 1, norm priority is 5, max priority is what? 10. If I want to give a value of 8, what will I do? Directly you can give 8. But that's not advisable. Always you do like this. Mean priority plus 3 you give, or max priority minus 2 you give. Means either lesser than 2 max priority or higher than 3 norm priority. Norm priority plus 3. So it will be, there you have clarity now. That's why they have given these variables to you. See this. Now max priority minus 2 means I am giving a lesser priority of 2 than max. Actually value is 8 only. Like this we give. Understood? So when you see code, they will be seeing the code like this. It's 8 only. I understand. But instead of doing that, now like this we give. Or you can also say what? Say norm priority. Sorry. Norm priority plus 3 also is correct. Means it's higher than 3 normal priority. It becomes more readable. Value is 8 only. Understood? Sorry, not that much. 32. Okay. So this is the one. Clear? So it will work, no problem. So fine. But the thing is, see, what if I give a value outside the range? Here's your question. 12. What happens? Outside, no? What? What if I give a value outside range? What exception? It will compile because the method needs what? Int argument. You are giving int only. You are not giving float, double and all that. It will compile. During runtime you will get this exception. Fine. So bring it back to which one? Max priority. Now one more thing is, see here when the main thread created first the child thread, for both actually what priority it is given? That you notice first. As soon as the main thread created it, it already had given a priority of 5. If you want to print here. I am changing that priority. Default priority what it is giving? 5. So which thread is creating? Main. What is the default what is the priority of main? 5. That is why it is getting the default priority of 5. If you want, you can change it now. So you can see it prints 5 initially. SOP T1 and T2 it is printing 5. If you want to put some print properly, priority of T1 is okay. Yeah. Then what else? Anything else in priority? Understood how to give the priority, na? This much of information is more than sufficient for priority. These are your interview questions related to priority. Any questions related to priority? Okay, fine then. That's it about priority. Okay.